we welcome Jürg Meyerhofer. The design and engineering of services is the common thread throughout the activities of Jürg. Jürg has been a lecturer, researcher, and project manager in the service science and service engineering at the Zurich University of Applied Sciences since 2014. In this talk, Jürg will present a design methodology based on a simultaneous maximization of value creation for both the provider and the customer. Thank you, Jürg.
Thank you very much, Anita. Yeah, good morning, or almost lunchtime already. Happy to have you here. I'm overwhelmed by the number of people that we have. Previous year, that was a tiny little group in the room, and now we have so many people. Very nice. So my talk is about, as Anita said, on the value of data, multi-objective maximization of value creation in data-driven industrial services. A frightening title, very long, very academic. Let me break it into pieces. We have two things. Actually, we have industrial services. I will introduce what we mean with that. And we have, oops, that jumps indeed by itself. And we have value creation and the maximization of value creation. So these two fields, services and value creation. So Karina said it jumps by itself before. Indeed, it does after a couple of seconds. Now, what do we mean with industrial services? You see here a couple of pictures to frame that topic. You see we have machines, manufacturing, production environments, and we have people working on these machines, producing with these, maintaining them, getting more value. And services are about helping customers, helping people getting more value out of this equipment. That's the topic of industrial services. And now you can immediately see this is a data-rich environment. There is plenty of databases behind this equipment. And so people, managers, companies want to leverage that data. They would love to use that data because they assume there is value in it. But first, they are afraid of security, legal things. And second, they don't know if it brings value. It costs. We can roughly estimate what it costs to use that data, but how much will we get back? Show me the value. That's a typical question. And that's the topic of that talk. And to warm up, I was motivated by the organizers to have a poll. Let's try it out. I have no clue if you cooperate and how long it takes, if my 20 minutes are over. But let's try. If you figure that, photograph that QR code, and then the operator switches to the results page, where we can see, now mobile phones are still up, so we wait some seconds. I've never done that in a talk. Ah, here it was. Yeah, cool. Yeah, okay, the bars are growing. Yeah, operator, could you switch back to the QR code? There are people still. Yeah, and now the slide here, yeah. I have two of these slides. Maybe I omit the second one if it's too much a hassle for you. So now I guess we can switch to the results page. Yeah, there's a reload necessary or. Ah, that's good. Okay, that's cool. So I actually expected that most answers will be here. So we have a little bit more here that you don't even know how to assess the value of data. Then the second is you have qualitative methods. That's what I also experienced in my research work by now. And still some of you have quantitative instruments. So I would be keen to talk to those people who selected that one here, the third one, that you have some here. But nobody is really on the strongly agree side of that measure. So we go back to the slide. Now, I jump over that. To frame the topic, we are in the service area, and there is a science which is called service dominant logic, which claims that service is the basic fundamental of any economic exchange. Why do I bring that? Because we are in manufacturing environments, and these companies here, they produce machines, equipment, products. How can we now talk about service as the basic role of exchange? Because users are applying this equipment and value is created while users are interacting with your machine. And that's a kind of service thinking. And you see here, they claim that goods, machines are a means for distributing service value. Means that customers do not want to own your machine, they want to get the output of your machine, the result. For instance, of a vehicle, they want to get transport, they don't want to own the vehicle. You know that story. So that's the background of that talk. And now when services become digital, instead of the first picture where people were acting on the machines and the material directly, people start interacting with screens. And behind the screen, then there is the equipment and the shop floor. And an interesting thing is that topic of remote service. We had it also with Karina on one of her slides. There may be somebody sitting in Central Europe, for instance in Switzerland, and your customer may be 10,000 kilometers apart, and you can provide service to your customer over the internet. Eventually, without any manual interaction, eventually you need somebody on site doing some manual actions, but you guide that person from your headquarters here. And that, of course, provides a lot of value, performance increase, and also ecological value. You save a lot of traveling and things like that. Now, another concept that I want to introduce, and that's the last concept before we go to the value topic then, we consider service as something that deploys over time. It's not a one-time instant thing. And we have a typical customer life cycle, starting with the initiate phase, where we market the product, we try to find out the customer's needs, what do we need to sell, offer the customer to help the customer in its production. Then we have, when the customer has purchased the machine, the expand phase, which is kind of the learning curve at the beginning of the life cycle. Here the customer gets acquainted and familiar with your product, and at the beginning here the performance is low, and then you ramp up the performance through a learning curve as fast as possible. In industrial products, that may last easily weeks to months until the customer is really up and running high. And then we have a long stabilized phase where the customer creates value with your product day by day, year after year. That may last 5 years, 10 years in industrial equipment, where the customer uses product and you help the customer getting more out of it by services. And anything comes to an end, so one day the customer may decide to leave your product, to give it up, and here you may try to keep the customer by helping getting more value out of the equipment, extending the lifetime of the customer, the product with the customer, getting more value, and also then getting more value of the equipment and saving CO2. Again, an ecological aspect as well here. And we will use that framework throughout the talk, throughout the concept. And now, how do we assess the value of data? First we had the poll, do you know how to do it? And now the question is, how do we do that? How can we determine what's the value of data? We went into literature and we did an empirical research. We talked with 15 SMEs, management layer of SMEs, and we found those three concepts. One is that people say the value of data is the market value of data. What does it mean? You put your data on a marketplace and you look what customers, potential customers are willing to pay for it. The second one is cost-based. You say, how much does it cost me to get the data, to process it, to store it, to analyze it, and so on. And that's then the cost-based approach. And the third one is the utility-based approach, where you say, what can I do with my data? How can I create benefit for my customer, my user? And that benefit then determines the value of data. You see three completely different approaches. Now, at this point, I had planned a second poll, but I suggest that we make it by raising hands, so we are all present in the room. So what do you think? Can those who think that that one is the most important for services raise the hand? Nobody, okay. The middle one, cost-based approach. Some of you, okay. And the third one, utility functional, most. Okay, we agree. So that was a suggestive question. Indeed, for services, the utility-based, functional-based approach is the most important. Why? Because by services, we want to help customers doing something better. And if we apply data and help doing something better by data, that benefit in the customer's process determines the value and what the customer is willing to pay. If you cannot help your customer with your data, the value of the data is zero. So it depends on what the customer is doing with that data. The customer may be an internal user, of course. Now, the research question can be framed like that. How do we design utility-oriented, data-driven services along these 4 phases to optimize value, not only for the customers, but also for the provider? We are in an economic system where, as a provider, we need to create value. And that's our value exchange model. We have here, on that side, the customer having an equipment, your machine, which creates data. The customer sends that data to the provider, which is the first kind of value flow. The provider creates data models, and by that data models, by that help, creates better service for the customer. So we have a value that the customer gets, we see, and the value that the provider gets, we P. And you see then we sum that up over the 4 steps of the life cycle for both sides. Here we normalize it to the customer lifetime. I do not explain why, it's in the paper. All these pictures and formulas are in the paper as well, in the proceedings. And now along these steps, we can apply different levels of data intensity to do more or less leverage of data to help the customer getting more value and then get more value back. That's the value exchange model. And there's another concept of theory, which we took from the literature Michael Porter, quite a famous guy, and Jim Heppelman in 2014, saying that if you increase the leveraging of data in connected products, if you do nothing, you are below here in the white space, then you can do a little, which means monitoring the customer's operation or product. The next level is apply control, so act something on the machine. Then the level higher is optimization, and that means maximizing or minimizing something in a mathematical way. And then at the top level, we have autonomous systems, meaning self-organized systems. We apply that scheme. Now, what did we do? We took those 4 steps, as I explained: marketing phase, selling the right product to the right customer, learning, getting most out of it during the operations phase, and then end of life cycle, keeping the customer back or creating value there. And now you see we took an example set of services. We could actually take anything out of this triangle, but we took, to illustrate an example, in the initiate phase, we can leverage data of the customer to find out what are the customer's needs and which is the best offering that we can provide to the customer, versus using no data, no targeted offering. Mathematically, this is represented in the take rate, a higher probability or lower of the customer taking our product, getting the right product, and our waste in our marketing process. The second step, when the customer learns, we can use data from the customer's operations to learn exactly where does the customer stumble, where do we need to help the customer. That's really a tricky thing here. Where do we need to help the customer? And provide services to enhance the learning curve. You see here, a learning curve is kind of an S-curve approaching 1 over that time here. Or we do nothing. Then in the stabilized phase, we have the full range of standard services doing nothing special, monitoring, remote service, condition-based maintenance, performance optimization, and here we have mathematically a performance level function denoted by alpha service. And in the terminate phase, when we see that the customer is going to leave us because there are problems, that the performance is going down of the machine, if we learn that by data, we can apply targeted retention. For instance, offer an add-on to the product, offer a coaching, a service, whatever, to help the customer stay with us. And that has an impact on the churn probability, the win-back probability, and in the end of the customer lifetime. So it keeps the customer longer, staying longer with us. And these levels here, going up 1 to up to 5 there, means increasing data intensity, applying more data. Now, just a short glimpse, don't read that. These formulas are in the paper, but for each of these steps, then we applied a set of formulas to calculate the model. And the research question is now reframed. Which combination of these services in this table here, in these phases, optimizes the values for the customer, VC, and for the provider, VP, in a combined way? So that's the reframed research question. Now we have the topic here. We have these data intensities, means the layer on that, how many services we apply per step, T1 to T4, across these phases. And the question is one, which vector, D1 to D4, provides maximum value? There's one problem. Maximum value means both of these. Value for customer and value for provider. How do we do that? We have two variables. Now, a natural reflex would be to sum them. Take the sum of both. VC plus VP and maximize that. We cannot do that because customers and providers have completely different value contexts. What helps us here is the concept of multi-objective optimization, Pareto optimization. We take the two variables, we create all possible combinations of these input variables and create a scatter plot. And what we find then, we have all points below a line here. And this line is called Pareto front, which is an efficient front. And if we find a combination of data intensities that resides on that line here, then we are optimal, and anything that is below is suboptimal. If you're on that line and you want to improve the value for the customer, means going up here, VC, you can only do that by decreasing value for the provider, going to the left. If you're below the line, you can improve both of them by moving out to the line. So we have the optimal points on that line. There's still one puzzle open. Let me show what we did then. We took these combinations of services. You see 2, 2, 5, 2 gives a combinatorial quantity of 40 points. We took those 40 points, plotted them in such a scatter plot. This is just an example here. Here's the real calculated plot now. You recognize that we have given a label to each point. This is D1, D2, D3, D4, meaning, for instance, if we have a 1 here, that means we took the lower level of intensity in the initiate phase. If you have a 2, the second level in the training phase, and so on. So, for instance, up here, where there is a 5, the third position means in the stabilize phase, in the long operations phase, we have the highest level of service intensity chosen. And now we also see that we have here that, indeed, we turned out that we have that Pareto front, the dots connected by the black line. And one thing that we can learn here, we do not yet know which is now really the best one. We have a multitude of points which are optimal. Now, it's the open question, which is the best? And that depends now on our strategy. Look at, for instance, the point up here. You recognize we do quite a lot in marketing, in training, in the stabilization phase, the maximum, not so much in retention. That creates a lot of value for the customer, but costs a lot, creates costs for the provider. So that's why we are here quite on the left, but up there. As it's opposed on the other end of that line, you see that we do a lot for marketing, 2 here, then we do almost nothing for our poor customer, 1, 1, and then in retention, to keep the customer, we do again as much as we can. We are quite egoistic here. This is altruistic. Now, both are optimal. It depends on our strategy. If we are in a highly competitive market, we need to do more for the customer, less for ourselves. If we are rather in a monopolistic market, not much debated market, we can rather go to that point. I do not judge that from an ethical point of view, what is better. Another thing is, you see, those points are not intuitively found. For instance, we have here always a 2 at the end, meaning we do a lot for retention on that optimal line, and suddenly, from that point to that one, we omit retention measures. It becomes more optimal to do not retentions. This is due to a non-linearity in that model, which we explain in the paper. I don't have time here to do that. But the message is, finding the optimal points is not intuitive. Without such a model, you would land just anywhere. You would choose one of these points. Why don't we do here and that? Management judgment would land somewhere here below. So with that, I come to the conclusions. The model allows to quantify the value of data in a real operational setting. It results in things that are not intuitive, we wouldn't find without the model. And this integral approach, taking into account all phases, all service intensities, and the impact on value of costs for providers and customers is absolutely relevant to achieve these results. The whole thing has, of course, limitations. The parameters are chosen here for an archetypical model, but we want to know how is it in real company data. And we are right now in that phase of research that we work with companies and try to assess these values for real company cases. And if we achieve that, that's the next step, We can go to any company, assess in some interviews and some measurements the parameters, and then plot them this strategy curve. Should be something like 1 day effort, if we manage to do that. And the company can then decide on its service strategy, which is not given by management gut feelings. And we want to extend to simulation-based models for details, as well as to an ecosystem perspective, having more than 2 actors. I thank ZHW Digital for supporting that work, and also we had an Interreg grant from the Bodensee community. You see here, Eidgenossenschaft and European Union funding that work. That's the end.
So we have time for some questions. If you have any, wait for the microphone, please.
At the beginning, I omitted one thing. I thank Rodolfo Benedek and Christoph Heitz. I was prepared to say that, and at the end, I didn't say it. Yeah, please.
Thanks. Is it on? Yeah. Thanks for the talk, Luca from Swiss Re.
Yeah, hi, Luca.
I'm curious to understand how your model or approach could take into consideration the asymmetry of uncertainty between costs and value.
Of uncertainty?
Yeah, normally we know what the costs are, but the value, it's more of a guess estimate, or there's a lot of uncertainty. So how could you take that into consideration?
Yeah, that's what we would do in that case, in that curve here. We would create a sample of curves having the extremes, so the range of uncertainties that you included. So in those parameters, in those formulas, we include the benefit variables that you get on that benefit side that you say which is uncertain. And I would do their kind of Monte Carlo sampling, meaning swiping through the uncertainty range and find out the sensitivity of these curves to see. Eventually, it's not very sensitive, it's eventually very much sensitive to see that effect, yeah.
I think
Thanks for the presentation. It's Karim from ION. I was wondering, in the study you did, do you have companies that all come from the same sector, or do you have? Did you observe some differences across sectors?
It's all from manufacturing, all SMEs. Why do we take SMEs? It's the same problem for corporates as SMEs. We take SMEs because they have more need for things like that. Corporates, they have rather other structures helping them just trying out something. SMEs cannot invest before they know what it brings them back. There is, of course, different... that's really a funny slide set. I cannot go back anymore to my slides. Thank you. There is, what we found, there is a big difference in which phase the companies have their focus. We see some companies for which, like an expand phase, customer learning curve, is no problem, because anyway, it's crystal clear, or they're always on spot, whereas they have a lot of focus here. We have other companies selling the right product to the right customer need is the biggest problem. They have large fleets out there, and the customers have the wrong, underutilized or overutilized tools, the biggest problem. So we see in those steps big differences, big nuances. Also, when we do now interviews and field observations, in some cases we have empty answers in some of these columns and full answers in others. And then we need to mix that up somehow. Yeah.
question there. Should be time.
Thank you for the nice talk. I was wondering, have you ever tried to validate your model and your simulation against semi-real market condition, or to evaluate if the value that you predict actually is mirrored, knowing the true data?
Yeah. Two components to your question. Thank you for the question. One part is what we do right now. Real market conditions take in input variables of real companies. In the output side, that's a good point. We are not yet there because it's often difficult to have a ceteris paribus comparison. If you apply the service, you have no equal case to compare it without service. So that's what we actually want to do with that model. We want to help SMEs in investment decisions. if it's worth investing, how much do they get? If they really wouldn't have got that benefit without applying it, that's a difficult thing. Not yet there, but a good point.
Thank you very much for the questions. Please don't forget to rate the speaker in the app. Thank you very much.
Thank you very much, Anita.